Everybody having a good day? Good. We're here to talk about some stuff. We're not sure what, but just some stuff.
All right, looks like we've got about 3 minutes.
Yep. First KubeCon? Who's here the first time? Holy cow. That is awesome. Over 4 KubeCons. 2016? Anybody over 2016? All right, you got me. Who here contributes to Kubernetes? Who here contributes? All right. Again, who here wants to contribute? That's better. It's a really neat community to get into. And we have a lot of technical debt within the community. So if anybody wants to help out, please, you can reach out to me or Paris Pittman, who heads up the community organization. Dos. See? 2 minutes. What's the over-under if we have too many slides?
We probably have about 15 too many slides.
Yeah, no, we have 25 minutes to get through them. Be fast. Make it interesting. I knew Etsy was big, but I didn't know it was that big. It's huge. We got free spaces over here if you're looking for a seat. This is awesome, really full crowd today.
I guess before we get going, how many folks here use Bazel already? All right.
Let me ask another great question. Who here is actually happy with their build system? I am. That got a nervous laugh. I got some other evil questions that are coming your way, don't worry. All right, shall we?
All right, let's go. Hello, KubeCon. My name is Gregg Donovan from Etsy, and this is?
My name's Chris Love. I'm with a company called LionKube, with K.
And we're going to be speaking today about streamlining Kubernetes application CI/CD with Bazel. So let me start by giving a little bit of background about Etsy and our adoption of both Bazel and Kubernetes. So what is Etsy? Etsy is the global marketplace for unique and creative goods. We're headquartered in Brooklyn in the US. We've been using Bazel and Kubernetes for 2 years, and our entire search platform is built with Bazel and deployed to Kubernetes, specifically GKE. So Etsy is a large international and rapidly growing marketplace. We have nearly 40 million buyers and over 2 million sellers around the world. We also have offices around the world. The closest one to us today is our engineering office in Dublin. And we are constantly trying to improve the product to keep up with our buyers' and sellers' needs. So that makes development velocity our #1 concern. So I work on search at Etsy, which is an especially fun problem, as the handcrafted items we sell are each unique. And so search combines large-scale machine learning problems, systems challenges, real-world impact, and lots of interesting products to think about. And with problems of this scale come the challenges of scale. Among those are the challenges of scaling out build, test, and deployment. We have thousands of tests in a large multi-language monorepo, complex stateful applications to build and deploy, and we have dozens of engineers working on our stack who need to rapidly test changes and validate the correctness and performance of those changes. These challenges are what led us to both Bazel and Kubernetes. So Chris is going to tell you more about Bazel.
And why don't we start off with Blaze, and I'll take that clicker from you. Clicker. Thank you. So why don't we start off talking a bit about Blaze. Blaze is actually the predecessor to, yeah, you know that slide. Sorry, somebody's already given me spunk from the front row. So let's talk a bit about Blaze. Blaze is actually the predecessor to Bazel. It's an internal tool within Google. They had to build it because of running into slight googly problems. Bazel is now the open source version of Blaze. And they had to make it, Google had to make their own build tool because they had to. They have a very large code base. They also have a testing, or a standard of testing. Within Google, you have to test your code. You have to test your code a lot, and then you have to test some more. And they have a lot of code. So let's talk Linux kernel. Pretty much runs the internet, right? Talking about 200,000 lines of code. I think we know this project. All right, it's the largest actually open source Go project in the world. We're talking right about 2 million lines of code that are, some of it's generated. Talk about Windows. It's 50 million lines of code approximately. Of course, it's closed source. And then we have Google. Yeah, I messed up the scale. Let me see if I can fix that. Nope. Let me see if I can fix that again. Yeah. Just look at that number for a second. So every day, they have to build that code base. They build it multiple times a day. They have approximately 60,000 changes to their code base a day. These numbers are about 4 or 5 years old, by the way, that were released. So we don't even want to talk about where they're at now. So when you're talking about code at this size, you're talking about big code. When you have a lot of code base in a mono repo, you're talking about huge builds. And then, yeah, we're talking about let's test it, which gets really fun. So you might be going right now, I do not have that many lines of code in my organization. I understand. I don't have a mono repo. I understand. Bazel's not just if you're at Google. All right, let's be clear. I don't know anybody else that has that many lines of code. So we all use build tools here. I took a quick straw man poll of who's really happy with their build tools, and I got chuckles, and very few people lifted their hands. Who here can guarantee that they can rebuild a commit that was put in 2 weeks ago? Guarantee. Yeah, I like that. Who here has ever had an issue with rolling back where they couldn't build their commit? Oh, come on, be honest. Be honest, it's okay, we've all been there. So one of the key things about Bazel is being deterministic. I'm not gonna go into this big, long, wonderful, sentence structure about determinism. This is what we all strive for our builds. An old build can be rebuilt. So we've always had, we install the new language library on our build box. All of a sudden, we try to do an old build, and there goes the build. Bazel strives, if you use it in the manner it's set up to, Bazel strives to have reproducible builds all the time. And builds have to be hermetic. So what that means is that we've got system libraries on our build box. We've got a JDK in our build box. We've got Python on our build box. We have Ruby on our build box. Your build should not be using those tools. Your build should be completely encapsulated in its own little bottle. It should be hermetic. So let's talk about some feature functionality as well. Dry testing. Don't repeat yourself. If you tested it and you didn't change that code, why are you testing it again? With most modern unit testing tools, you have to run the entire test suite again, even if you didn't change any code around it. Parallelism. We're talking at times about a lot of code. We're talking about wanting to be able to deploy 300, 3,000 times a day. In order to do that, we have to do a lot of builds. in order to do a lot of builds, the builds have to be fast. With parallelism and also with pooling and caching, you're able to get the type of performance you're looking for. As well as a developer who likes waiting for their builds to be done. Yeah, nobody, all right? Developers often go play foosball, go get a cup of coffee when they start their builds in the morning. As well as I was mentioning, remote builds. This is a fairly new feature within Bazel, and there's some tooling coming out around it. It allows you to have a pool of workers in the cloud locally if you maintain it. And with RBE, which is a Google Cloud product, you're able to plug right into Bazel and fire up a worker pool, and you're able to not only have the horsepower of your build machine, but you're able to have a dynamic cache as well as dynamic horsepower behind your build from that process. Languages. Who has multiple languages that we build within their repository? Wow. So Polyglot is here to stay. This is a short list of the languages that it supports. So, and it's built and it's modular so that we can implement more language support easily. So let's just get a quick background of what Bazel is. So within there, you've got a workspace file. You open up a Bazel project, you got a workspace file, and you have a workspace. It's basically the root component of your directory structure. Within the workspace file, you're able to define lots of different things. Typically, you have workspace rules. You'll notice that we're pulling in a dependency. We're naming our project there. So we're pulling in Go. You'll notice that we're also pulling in the SHA. So not only are we downloading that from GitHub or your location of choice, we are checking that it's actually the download that you should be getting. Kind of important. Also, build files. So most directories within a Bazel project have a build file, which is named build.bazel or build, depending on which day it is. You'll notice within here, we're pulling in, we're loading components that are actually Starlark components. Pulling in what's called a K8s object. We'll talk about more later on how Kubernetes interacts with Bazel. We're able to alias those objects. So if you notice, we pull it in, it's called objects.bazel. Now we're going to call that K8s objects. Then we define some stuff. One of the interesting things about Bazel is the path notation you'll have to get used to. So you're looking at a line that says actual there. It says // JS clients /source, blah, blah, blah. So what it is a file structure. / means a directory. / is your base directory, your workspace directory. Then going down from there, we've got a JS client folder, we've got a source folder, and then we've got actually a file or a definition, an alias. That's your tsconfig.json file. All right. Now, Gregg, I'm going to hand it off to Gregg here. He can talk a little bit about how Etsy uses Kubernetes and Docker with Bazel.
So at Etsy, as I mentioned, we deploy all of our search services to GKE using rules Docker and rules Kubernetes that Chris was describing. And we spend a lot of time investing in this stack to try to make it as fast and as powerful as we can. And the stack offers fast, reproducible builds, especially for container layers, and programmatic control over the generated YAML for each different environment. And this approach really shines with a multi-application monorepo. When you change shared libraries, deb files, tooling, et cetera, base images, you need to know which components need to be redeployed and which don't. So in a simple application, you might be able to keep this all in your head, but at scale, you need automation. So I'm going to talk about why we use Bazel, rules Kubernetes, and rules Docker, and how it gives us fast, correct deploys. I'm also going to offer some general Kubernetes and Bazel tips based on our 2 years of working with Bazel and 2 years of working with Kubernetes and doing a big migration to GKE. So when we started using Bazel, one of the best features we noticed is that Bazel's reproducibility and caching change our entire local development flow. Instead of working on your code and then rerunning the specific test or tests that you think is affected by your changes, Bazel enables you to run all the tests all the time and let Bazel figure out what needs to be rerun. This totally changes how you work every day. And since Bazel has a full directed acyclic graph of your code, it can figure this out for you. So when we saw this, we wondered if it would be possible to bring similar benefits to deployment. Can we make code changes, deploy everything, and then let Bazel and Kubernetes figure out what actually needs to be redeployed? So this is sort of our ideal deployment workflow. We have dozens of deployments, hundreds of Kubernetes objects. We don't want to have to keep in our heads which one of them has actually been affected by a given commit. After all, there are edge cases. You might have a shell script that is depended on by multiple app containers, but transitively by a sidecar container. It's very difficult to reason about this stuff. So achieving this idealized workflow is quite challenging now. Unless we have a reproducible build, every time you do a new build, it will appear as if there are new artifacts to deploy. If our build artifacts have changed by a single bit, it will appear as they are new and they'll need to be rolled out. And these are just some of the challenges to reproducibility. For example, most file systems do not guarantee that listing files in a directory will always result in the same order. tar and jar file archives will by default include creation timestamps. All of these break reproducibility, but Bazel is designed to handle these challenges. So Bazel's rules Docker is a set of Bazel rules for pulling down base images, augmenting them with build artifacts and assets, and building container layers. It also offers language-specific rules that make it easy to go from a binary, say Java or Go main, into a container image. The interesting thing is that you do not need Docker to run the Docker rules. So if you run into issues with Docker in your CI or CD environments, or running Docker within a Docker container to build images, this removes that problem from the equation. And Bazel's rules Kubernetes is a set of Bazel rules that enable deploying templated YAML and container images to Kubernetes. It allows you to do authentication, publish containers, publish your container digests, container YAML, do basically full application lifecycle, and choose your own templating technology. In Etsy, we use custom Python code, but we also use JSON for other applications, and you could use Helm if you like. And with this approach, we avoid two problems. Under-deploying, not deploying components that have changed, leaving them unvalidated on master, and over-deploying, waiting for a potentially expensive rollout despite having not made changes. So we can radically simplify our CI/CD flow. We can have a single pipeline for building, testing, and redeploying all of our applications, relying on Bazel to negotiate what actually needs to be deployed with the container registry in Kubernetes. So how does this actually work? So let's dive into some of the details. How does this negotiation between your build and the container registry and Kubernetes actually work in practice? So fortunately, Kubernetes is smart enough to only deploy what you change, and it does this by hashing its inputs, much like Bazel. So these hashes include both the YAML and the exact versions of the containers that you're deploying. So in this case, you can see spec.template is hashed, and the SHA-256 is stored along with your deployment. So Kubernetes knows if it sees that same SHA-256 of spec.template, it doesn't need to do a rollout of your deployment. And taking advantage of incremental deployment in Kubernetes requires that you can deterministically generate all of your inputs, including your containers. Otherwise, every time you do a build, you'll generate a new container version, even if it hasn't changed in a meaningful way. Rules Docker provides rules for generating container images deterministically, allowing you to build a single repeatable package from base container to your own application code. In the example above, you can see that Bazel has helpfully stripped out dates from our containers. And it seems a bit odd that code that you wrote today appears to be from 1970, but it is very helpful to get repeatable images. Otherwise, just the simple change of dates will cause Kubernetes to redeploy them. And then rules Kubernetes builds on top of this. It takes as input a set of Docker images that you want to build and what are their Bazel build targets for generating them. And it takes an input Kubernetes YAML with placeholders for the images, so unresolved. It builds your containers, pushes them to the container registry, gets the SHA-256 of each container, and then it substitutes those SHA-256s for the placeholders you had for your images. And so the final thing that gets sent to KubeCTL apply is your generated YAML with those SHA-256s appended to each of your container images. So digging even deeper, just what is a container? So a container is an ordered list of tarballs representing file system layers. Each layer itself is represented as a SHA-256 of the uncompressed contents. The overall image is a SHA-256 of the layers and the metadata. So Rules Docker builds these layers with custom tool chains written in Python and Starlark, a Python dialect used by custom Bazel code. And Bazel's Rules Docker removes the complexity of actually running Docker in CI/CD and allows Bazel's parallelism and caching to speed container layer building. And it builds on the standard container registry v2 API, which provides caching from local build to the remote container registry. And Rules Docker uses its HTTP head request support to check for an existing SHA-256 of an already cached container image or the SHA-256 of a container layer. This removes the need to re-upload container images and layers that are already present in the remote registry. So if you do build and nothing has changed, all of these HTTP head requests are going to see an existing cached layer, an existing cached image, and it'll be basically a no-op between your local build and the registry, so very fast. Finally, a Kubernetes deployment hashes the pod template to determine if your application needs to be redeployed, and if the pod template hash is unchanged, there's no need for a rollout. And so with this, you have the benefit of Bazel's reproducibility from your source at the bottom to your Kubernetes deployment sort of at the finish line. And Rules Kubernetes offers a number of other features. And an interesting one that we've really taken advantage of is the ability to provide your own KubeCTL version. There's some weird edge cases here and there if the KubeCTL version you're using differs from the server's version, and it's nice to not have to deal with them and debug them because they can be very tricky. So you can specify the KubeCTL version right in Rules Kubernetes. It will make sure it builds from source, so you could actually potentially provide a KubeCTL patch of yours and build from your branches SHA, which is pretty nice. And Rules Docker has some really nice other features. And the one we've gotten the most mileage out of that you don't see with a Docker file is Docker file is sort of serial from top to bottom. Whereas Rules Docker, you can think of your container layers as these Lego bricks that you can use to assemble your application containers. So we have reusable layers for things like instrumentation libraries, gcloud, gsutil, other reusable things we might want to add to application containers, but not have to layer them in. And so rather than stuffing everything into a single bloated base layer, we can assemble these Lego bricks. And so a few tips from our sort of 2-year migration from on-premise infrastructure. So we previously ran our own data centers and ran Kubernetes on-prem before moving things to GKE. And so one thing we would recommend is the distroless containers. So a lot of your application containers you deploy to Kubernetes, they don't need the full operating system. So Google has this distroless project that provides just the bare minimum you need to deploy an application. So given your main method, so for Java, that's glibc, SSL, the JVM. It's very minimal. So you get these nice small Docker images with a very limited attack surface. And as I mentioned, SHA-256s are, I think, a best practice. So even if you're not using Rules Kubernetes or Rules Docker, Helm supports these, Scaffold supports these. A lot of the different Kubernetes workflow tools support them. It avoids the violation of immutability you get if you use a tag. So a tag represents a potentially moving target. And many Kubernetes users will eventually have this giant wall of YAML. So for the complex YAML building use cases we have at Etsy, we use custom Python code. And the client API is very nice for this. If your use cases are simpler, Customize is great. There's other good tools. But don't hesitate to use the Kubernetes client APIs if the complexity of your YAML generation is really overwhelming and sort of pushing past the limits that these templating tools are designed to deal with. And Tilt is a great tool that we've been using to try to understand what's happening with Kubernetes deployments. There's a lot of playing 20 questions with KubeCTL if your application's not working, and Tilt is a great tool that we've really liked for diagnosing what's happening, pulling all the logs together, seeing what's wrong with the deployment. And the Tilt folks are here at the conference. They're very nice. I'd recommend you go talk to them. And using CRDs for cloud resources. So Kubernetes custom resource definitions are very powerful. I'm sure a lot of different talks about these, but the different cloud operators are adding CRDs for their cloud resources. That will allow you to use your same KubeCTL apply for things like GCS buckets or S3 buckets. And we invest a lot of time in these Kubernetes CI/CD pipelines. If you use these CRDs, you get to take advantage of that. And now Chris is going to show a demo of Rules Kubernetes, Rules Docker, and Bazel in action.
Thanks, Greg. And I want to talk about one thing that Etsy does that's really powerful. One of the main complexities that we're running into as developers and as operators of Kubernetes is YAML. It can get just to be a mess. 400 YAML files all over the place. If you take it, you put it into code, you're not only able to get rid of some of that complexity, but you're also able to test it, which is huge. All right. So the demo is available open source. Got the shortened link there if you want to take a picture of that. It's a small web application that has two different components in it. First is Angular web front end, and then you've got a Java REST service for one of the Angular pages or tabs or whatever you call it in Angular. We've got multiple languages, so we've got Java, we've got TypeScript, we've got JavaScript, and if we call HTML and CSS languages, we got those too. We're doing unit testing, so we're running JUnit. We're also using Protractor and Jasmine. So we're actually spinning up Chromium in headless mode and running checks against the web page dynamically during our Bazel build. All right, let's go on the demo and let me see if I can switch this around successfully. All right. And of course, I cannot see that screen, but that's all right. To set to mirroring so I can see the actual screen here. There we go, displays. Arrangement. Mirror displays, yay. All right. Now, let's make that a little bit bigger for the folks in the back row and folks like me that are a little. So I've got a build box up in the cloud right now that I'm going to use specifically because I'm using RBE and it's really fast. So we've got a project here. And there's a clean command, if I can run it correctly. 7, 5, 6. There we go. So clean command basically cleans out the cache, local cache that is. So we now have, as soon as it's done here, we're going to have nothing on disk that's specific to our build. We will have some dependencies on disk. Now, we're using RBE with this build, so we've got a pool of workers sitting around that have already got the components cached. So I'm going to run this command right here. So we're looking at targets here as the big number, and it keeps going up. And we also notice that we have a bunch of stuff happening locally and remote. We've got TARs being built, we've got JavaScript being compiled, we've got tests being run, we've got all kinds of stuff happening. And you'll notice there's 43,533 targets in this build. This is a small application. Has no JS, so that really helps us. We're compiling Kubernetes or kubectl, so that really helps us as well, get us a couple more targets going on. But you'll notice that, yes, the JavaScript rollup does take a while. But nothing was cached locally on this machine. And you're noticing that we're even pulling in remote tarball layers. As Greg was describing earlier, a container is broken up into various tars. So we're able to package each one individually. So we ran 4 of our unit tests, which, hey, they all passed. And we looked at about 43 seconds of compile time and 51 seconds of compile time with approximately 43,000, is that right number? Yeah, 43,000 different objects that Bazel touched, looked up, compared the hashes, make sure that nothing has changed. All right, let's make a test and break stuff. So as I mentioned, we have a Spring Boot application, actually. And we've got a controller. And instead of saying here, I'm going to say hi, KubeCon. All right, this is just a Java controller with Spring Boot. All right, let's run that test again. Now this time it's going to run a bunch faster because we've already got stuff cached locally. And I wrote a test for that controller, and unfortunately, I forgot to update my test. All right, so let's go in. See if I can actually remember my paths. Source test. Oh, there it is. So it says here, and it should say, hi, KubeCon. All right, let's run the test. Again, make sure I didn't touch anything else. You notice that I've got a bunch of different command line arguments on here. I've got what's called a Bazel RC file, really important. It's about 300 lines of different configurations, especially with RBE. It comes a little bit complex. But fortunately, we've got the RBE folks give us the full bulk, 90% of the build file. And you'll also notice that I'm defining a couple things. If you look at, I'm defining a cluster. So that's actually my context in kubectl. And I'm also defining the container registry that I'm using. And those definitions are dynamic at build. So say we have dev, we have test, we have different container registries that we're using. We can define those at the time of the build so that we have containers over here, we have clusters over there, and we made everything together. So test passed, great. So there's some irony here. Bazel's replacement for make, and I'm running a make command to install my containers. It shells out and runs some shell scripts and stuff like that. All right. Everybody notices the kubectl apply commands, but what you'll notice is that you can see the path that kubectl is actually running. We've compiled kubectl from Kubernetes source. So we're guaranteed that I have kubectl 13.5 or whatever version I specified in my workspace file. I have run into so many challenges with the API when we get a couple versions out and outside the standard of the API server. Do yourself a favor, even if you're not using Bazel, maintain the version of kubectl very, very strongly in your organization. So you'll notice a couple things here. You'll notice that the service that we applied, so our manifests have a service in them, that's unchanged. We'll notice that, though, that the Spring Boot server, or Spring Boot containers changed, so we modified that deployment. And what Gregg also talked about is, it's really getting powerful when you don't have to redeploy Angular. So we updated our microservice. We changed one of the servlet components, and all we redeployed is a single deployment. Think about it at scale. When you're doing 300, 400 deployments, 3,000 deployments a day, just the network traffic alone, if you redeploy everything. All right. Let's take a look at the application real quick. Let's make that a bit bigger as well. So, let's see if refresh the page works, right? All right, so we have a very simple application. As I mentioned, we have the REST controller that goes on the to-do page. So we can add a to-do here, say, hi, everyone. Say hi to everyone, add the to-do. Very simple controller, no database backend. It's an array list that's in memory. So when you redeploy your deployment, there goes your to-dos. So we've gone from, if we go back to this, we've gone from source code. We define our source code, we define our dependencies in Bazel, we define our tests. We then test. We have the tests run, then we apply the manifests, And in between all of that, the source code is built, the binaries are built, we got multiple languages, possibly cross builds happening. We then have containers that are being built, we have manifests that are being modified, generated, and then it's deployed to Kubernetes. And I did it by doing this. So that's what gets me excited, is when I can automate and actually make DevOps a reality. So that's my demo. We've got all of 2 minutes and 36 seconds left. Greg, any closing thoughts? Or actually, let's switch back. I'll switch back the page. You do closing thoughts.
All right. Let's see. My closing thoughts. Well, we want to leave a few minutes for questions.
Yep.
So thank you, everybody, for coming. And if you have questions, either ask now or this is our various contact information. Question over there.
Yep. As well as while we're getting the mic out to the person that's running the questions, evidently Greg's going to do that, but we've got somebody else that's standing up here to do it.
Yeah, thank you.
Talk a bit about where that demo is coming from. It's actually part of a Google project that we work with. It's called Project Helmsman. There's about 23 open source projects talking about different standards with GKE. Bazel is one of them. You had a question?
Yeah, so you were saying that you were building kubectl as part of your build to ensure you have the same version. Do you also compile your own compiler to ensure that you are running the correct version of your compiler and so on?
That's a very good question. So the question is, so we're building our own KubeCTL from source. Do we also then compile the compiler from source and the compiler's toolchain from source, et cetera, et cetera? So within Google, I think the answer is yes. Everything gets compiled from source. At Etsy, we cut it off at the
dependency
at KubeCTL, and then I think we use the binary of the Go compiler. But it's very interesting that you have the ability to keep pushing the source dependencies as far as you want them.
Yeah. As long as your source dependencies have Bazel laid out already, you're able to then include them. And then with the proper tool chains, you're able to, for instance, run GCC, a compiled version of GCC. And if that changes, and then Bazel knows that the dependency tree, and it goes all the way back, and every project that depends on that version of GCC is then recompiled and retested. It's pretty powerful. Other questions?
How would you do more complicated deployments with the rules Kubernetes, like canary deployments and stuff like that? How would that fit in?
Can we talk about Can we talk about search a bit? Internals?
Sorry.
So
like the
looking
Kubernetes deployments.
more complex, like
more complex
stateful applications,
yeah.
right?
Like canaries, for example, like weighted deployments and stuff like that.
Yeah. So it doesn't support canaries out of the box, but what it does support is Starlark, which is basically Python-ish. So it gives you a capability of doing programmatic deployments where you have dependencies, you have wait states, you have, okay, this has to happen first, you have dependency management. We've actually worked with Etsy in terms of tuning their Elasticsearch deployment so that we have stuff like rollovers, failovers, upgrades are all coming actually out of Bazel. So you're able to chain stuff together. Now, it takes some programming knowledge, it takes some internal Bazel knowledge, how to do it. It's not really, it's a little learning curve, but it's not writing high-performance computing. You know, it's not working on, you know, other really, really complex problems.
Yeah, we at Etsy, as Chris said, we use a lot of Starlark code. So Starlark is this Python-like dialect that you can use to do custom things with your build. And for something like canaries, we don't use like in-place canaries, like multiple deployments in a namespace. We use just a lot of namespaces and then having traffic go between different namespaces. So we have a single place where we define all of the different applications, all of the different clusters. We use multiple clusters and all of our namespaces, and then we generate Kubernetes objects for sort of the set of those, the power set of all of those things. And so we might test different container versions in different namespaces, different branches, things like that. I saw one question right there in the middle. Nope. One in the back.
There's one there, and there's one over there. So.
Oh, you're saying we're done?
Yeah, if you want to come
Okay.
up a little bit.
We're out of time.
That'd be great.
But we'll be hanging out if you have any questions.